afternoon and welcome to today's video. So we're going to be taking another look at the Solavox 16R19, also known as the ITT Ideal Colour 3226. Now, since last week we've had an arrival in the post, and the arrival is no less than an actual Philips branded TDA 2579 frame horizontal vertical IC hole controller chip. So what we're going to do first is we're going to get the back off. Now the set hasn't been powered on since last week, however, never ever underestimate what a CRT can hold in terms of capacitance voltage. So the first thing we're going to do is to whip off the back, and we'll just tilt the setup slightly so we can get to these bottom screws, like so. Off they come. There and there. Go. So carefully take the back off, and the first thing we're going to do is to discharge the tube, and to do that we have the crocodile clip, which I shall put onto this suitable earthing point here. There. The next earthing point goes onto the end of this screwdriver, and the screwdriver goes underneath the anode cap, which we will just lever up like so. There you go, make contact with the cap. You heard the click there. Well, the pop. Tube is now discharged, so the set is safe to work on. So the first thing that we're going to do is to bring the chassis out into a convenient service position, which, if I move the flex out of the way, is here. And actually that's quite nice, as that brings us into a nice position outside the chassis. Next thing we're going to do is to clean this all up. So there's a couple of reasons why I want to clean all the dust off of this. The first one is so I can see what the markings are on each of these potentiometers, and the second one is to see if there are any obvious failed components. So, you know, bulging capacitors, resistors that have literally split, anything along those sort of lines. Again, this little IC here, which will actually raise the camera up. So, not sure what happened there. Anyway, we've just given the board a clean. This chip here is our TDA horizontal vertical deflection controller chip. We also have vertical amp, horizontal frequency and horizontal phase. I think it's horizontal phase that I want to look at, which on the board is R607. Further up the board, R883 chroma amp, R876 FHT frequency. We've got TDA 3565, which I think is the PAL decoder. Don't quote me on that, but it does seem to be in a similar number range as some of the others. We've got what I think is the chopper transformer here. That's obviously the line output transformer. We have this one, which is, it's in German, 1 Einstellung adjustment. So that's an adjustment. Let's have a quick look and see what that would translate to. So eins, it's going to be one something. E-I-N-S T-E-L-L-U-N-G. Einstellung. Einstellung is the Einstellung effect. Okay, that's not really helping. I guess it could be pincushion, maybe, I don't know. Einstellung. Einstellung adjustment. Oh, hang on a minute, 115 volts. That might be HT voltage, possibly. I'm going to leave that one alone. I think the ones I need to focus on is horizontal phase, horizontal frequency, and vertical. So these three, 1, 2, 3, which are all centered around this controller. We also have a number of resistors that we can check. And certainly one thing that would probably be worth doing is if we do TDA 2579, 2579, we can hopefully get a pin out for this. So TDA 2579 data sheet. If we can get a data sheet, we can check voltages to that chip. If we're getting the correct voltages, so is a TDA, and that's the TDA 2579B and 2579C. I want the plain 2579. So let's have a look at images. So 2579 is one in Radio Museum. We appear to have a very blurry. Oh, that's for 110 degree application, so that's for the 45AX tube. So that same chip in B revision was used for FST tubes. In this case, that doesn't seem to give us any voltages. TDA. That seems to be an internal schematic of the chip itself. Let's see if that gives us anything. Does it give us? No, that's, you have to be a member in order to get any kind of information. Hang on a minute, 3565 might be the vertical deflection circuit according to that, so that might not actually be the power decoder as I first thought. Incidentally, this tuner board has got a mains isolation transformer on it, so that would make sense, seeing there's a lot of silicon-based logic on there, and an EEPROM of some description. Oh, come on, you can give me something, surely. 3654. Oh no, it is horizontal vertical synchronization, so this is an actual Philips data sheet, this, so let's see if that gives us anything. So 2579, we're going to have to go for the B because I can't find the plain 2579. Let's hope that the pinouts haven't changed. And you've got to subscribe to that one, that's quite annoying. Are there any others? Okay, I'm going to use logic and assume, which is always a very bad thing to do, that we're looking for either 12 or 24 volts. So let's just go and sort out this dog. So as I was saying before I had to go to the door, I'm going to assume we're looking for either 12 or 24 volts. Now, incidentally, through the post from purveyor of interesting stuff, wish.com, this has arrived, and apparently this is a multifunction tester. So let's peel the clear cover off the screen. Let's plug this in to this zero insertion force socket. Let's press start and let's see what it does. So it's not currently testing anything. So let's try, and if we tip the board up here, let's find something that's obviously a capacitor. So we're looking at, let's have a look at this one. It's a huge one down here. It's got these cool little hooks on it, that's nice. Ah, perfect, there's a diode here. Let's see what this does. It says it's a multifunction tester. Well, multifunction test this. So let's try the green one. And start. Testing. Still testing. Let's leave it testing for a bit. It's supported there quite happily. Let's see if any instructions came with it. Oh, there it is. It's actually a capacitor, apparently. Or is it on top of a capacitor? We've got a 40 picofarad capacitor, which that diode, funnily enough, does bridge onto, which is odd. Let's try a more obvious capacitor. So there is one here. So C 407. These are cool, these little clamp things, they're quite handy actually. Actually hold them on manually if you need to. It's more ideal to be able to have them just sit on there without having to hold them, but this might add capacitance from my hands if I do hold them on the actual terminal themselves. Right, let's hit start and see what it does. So that's going to do some testing. So 930.8 microfarads, apparently. 930.8 microfarads. Let's see what size 407 should be. So 407 was this one. 407 should be 470. Microfarads. So that one's a bit high. So I think we've actually found potentially a problem capacitor. Right, let's calibrate the unit first. So we've actually got this bag of components, which I guess might be for testing. So let's open that up. And let's grab out this capacitor here. So this capacitor should be 1 microfarad. So short, negative, long, positive if I remember rightly. Okay, let's start and see if it's measuring accurately. 982.6 nanofarads, which is almost 1 microfarad, so that is pretty accurate. So what I'm going to do is grab a piece of paper and write down that capacitor we've just tested, which I think is possibly a little bit high in value. So we're looking at something that's a little bit high there, I would expect. May not have a direct effect on our problem or a direct correlation to our problem, but the fact that it's high and it's in a similar location on the board does seem to suggest that it may potentially be a problem. So let's go and grab that bit of paper. Right, so that was capacitor there. It was I think it was actually C407 we were focusing on, so that was C407. Should be 470 microfarads. Was actually reading on board. It may actually be lower when you take it off the board. It was reading 900 and something. I'll say 900, give or take. So that could do with replacing. Next one we're going to check is C405. So C405. 405. Right, 405 is here. We do have some convenient little bits on it which we can test. So we'll go onto there and onto here. Hit start. That's testing. Okay, 405 is coming up at 465.1 microfarads. So 405 should be 405. This one here should be, if we look at it, oh, actually, 470. That's the 470. I've got the two mixed up. 405 is 470. That was reading up at 465. And it's C. So that was. Hang on a minute. Right. This is the problem when you don't have a circuit diagram. Okay, the one I tested first was C407. 407 is actually around 900 microfarads, and it's a 1000 microfarad capacitor. 405 is a 470 microfarads, tested at 465. So they're actually arguably serviceable. So the next ones that we'll look at is these resistors, which are around here, which we will leave those for the minute because it looks like those capacitors are okay. Those capacitors, do they come anywhere near the IC? They don't seem to. I think instead of faffing about, what it would probably be a good idea to do is get the set switched on. So first off, let's hook up this VHS deck. That was well worth the 18 quid that I paid for it, including shipping, so really rather pleased with that. That's good. That's a good purchase. First time I've ever bought anything from Wish, so it was a bit sort of touch and go as to what it would actually be like, if it would actually be any good or not, or if it would just be a big steaming pile of junk. Alright, I don't have a mirror to see the other side, so I'll have to go round and monitor what's going on. But what you would normally have is you would have obviously first off a proper workbench, which I don't currently have, and you would have literally a mirror around the other side where you can view everything that's going on with your set. So let's focus that there for a second. Let's grab the plug for the telly, put it over in here. And let's grab the plug for VCR. Get that turned on over there. Okay, before turning on the TV, let's get the videotape in. I don't have, unfortunately, a signal generator, so VCR should actually give us a white, blue screen. So if I turn this on, and if we go to AU, unusual picture, it's sort of black and white. So let's fiddle with the horizontal phase. Horizontal phase, I've got some colour coming back. Horizontal phase does nothing, unfortunately. See horizontal frequency. That's also doing nothing. Vertical amp. That just reduces the height of the picture, but nah, nothing at all there. Right, let's grab the multimeter. Set it to 20 volts direct, and let's measure voltages. Let's earth against something suitably earthy. Chassis will do. So pin 1. Actually, bridging those does something worrying to the picture. The tone of the change. Oh, that actually blanks the screen if you bridge those two pins together, which is to be expected. Let's see if it's an alternating voltage. So let's There's a capacitor here. With a broken leg. Right by... Oh, didn't like it that very much. So there is going into that one. It's 173 volts-ish. So C 528 we're looking at. C528. Yeah, it's actually broken. That's not going to help things. Certainly do with replacing that.
Has to be believed. It's the only way to live. A little boy with a big imagination. In the faraway forests of India, in a world filled with magic, and her father's boundless love. Be anything you want to be like. That you are, will be. When Ina said away.
Our new arrival is Sarah Crew.
Come on, Becky. Just make it over. Remember the magic?
She would be
Activities I thought I could tell you till I heard you talk about.
a very powerful enemy.
I'm afraid jewelry.
So I think the first thing we need to do is to replace that capacitor, because we're going to be on a highway to nowhere without that in play. So let's unplug the set and let's discharge the tube. So we shall start with that's onto there. Whilst we're in here, because the previous engineer said that the HT had flashed over to that chip, we'll do that as well. So let's go underneath. You can hear it cracking as it makes contact. Done, discharged. Right, I think the best thing to do now is go and warm up the soldering iron, because we're in for a bit of soldering work, which will be fun. So let's get that out of the way. First thing we need to do is we need to see if we've got an equivalent for this capacitor, which is a... I don't even know what that is. I'm hoping I've got an equivalent, but we shall see. So we'll do the IC. So take a photo of that in the chassis. Mainly so we know which way the notch is. The notch is facing that way. That's quite important for when we come to reassemble it. Right, let's go and warm up the soldering iron. So whilst grabbing components, I've actually noticed that we've got another broken component on the board, which is in a part of the circuit pronounced vertical shift, which is interesting because that's part of our problem is with the display. So that's actually quite good. So what we're going to have to do is just determine what size of resistor we're looking for, because as I say, no circuit diagram, so we're having to do some reasonable endeavour guessing. We are looking at a brown, green and red with gold. I think gold is the that's the tolerance ring, if I remember rightly. Gold means plus or minus 5% tolerance. So this is where it really takes me back to actually deciphering resistors. So green is 5, R is 2, sorry, 2, 5, and brown is 1. So 251 ohms. Closest I've got, is that kilo ohms or just ohms? So we've got 0 ohms, so 10 ohms would be, let's have a look. So 100 kilo ohms, 4.7 kilo ohms, 100 ohms, I bet you there's an app for that, as they say. Let's check. It takes me back having to do it this way. Was it 152 if it's going down? Do you read? I think you read. Gold is always on the end, and you read over to the right, I think. So, oh, the fourth ring's the multiplier. Hang on a minute, there should be 4 rings. So, only 3 rings, with the 4th being gold. So, that's 0.1 ohms, which means that this is a... Let's see if we have an app. So let's just pause the video and see if we can have an app to sort this out. So it looks like the type of resistor we have. So we're going to be going downwards. So band 1 is brown, band 2 is green, band 3 is the multiplier, which is red. 1.5 kilo ohms, plus or minus 5%. We have 470 kilo ohms, 2.2 kilo ohms. We don't have a 1.5 kilo ohms. very annoying. So we need 1.50 kiloohms plus or minus 5%. And it does have the gold band because it just does. In fact, what we could do is hook up the tester and see if it's actually failed. So we don't have one to hand, and it is R resistor, is it? R411, which is here. So I'm wondering if I can, just to see if I can get the set going, bodge it by soldering it together before condemning its R411. I'm going to go onto this end and up top this end. This is a real janky way of doing this. Unknown or damaged part. Let's try it again. Yeah, it might be a blown resistor, so we'll never get anything out of that. Let's try the one next to it, which is R. This one here. Let's see if that works. That's 414. If 414 has anything, some kind of life. .414 ohms apparently. 0.14 ohms. .14 ohms. Surely that's not right. This is where we really need a circuit diagram for this. So we have, I'm sure it's more than that. So that first resistor is totaled. So R414 was coming up as that. Right, I've got the resistor out, so I've unsoldered it. Let's see what it registers outside of the chassis. So let's connect up this end to that, green to this one. Actually looks very knackered, this resistor, to be honest with you. And let's start the test. Uh, 1526 ohms. So 1.5 kiloohms, that actually works out about right. So that resistor off board is actually okay. So 1.5 kiloohms. We don't have 1.5 kiloohms. We've got 470 kiloohms, but we don't have any 1.5s, which is annoying. Theoretically, you could make up something with two 470s and a 100 probably, but I don't really want to bridge resistors onto resistors because that just does not look particularly splendid, to be honest with you. So that one could theoretically live again, but for whatever reason that has corroded. Looking at it, it looks pretty manky. There's tiny little cracks on it, so it's quite possible when that's put under voltage that it no longer, or put under more voltage than the tester puts out, that actually no longer works properly. So we need R411. So R411 which is a 1.50 kiloohms. Now R414 was another query, because I'm not actually sure if R414, which is in a similar area on the circuit, is actually doing what it should be, or if it's actually the value it should be. So let's go top side and take a look at 414. So that'll be this one. So we will go green. And red onto there. So that should also be a 1.5 kiloohm resistor. And 933.4 microfarads. That's not right, it thinks it's a capacitor. Let's try that the other way round with red on that side. Still thinks it's a capacitor, doesn't make any sense. See if we get anything out of the multimeter. So we are looking at 2k ohms. Yeah, because it's 1.5, so there. 0.6, okay, it's got up to 200. That's way out of, is that way out of range? Yeah, it goes out of range there, so 414 measures out at 0.662, so that's 662 ohms, when it should be 1.5, I think. So R414 is measuring out at 660 ohms approximately. And if we do a calculation based just purely on the colour of it, 414, we are looking at, if we use the application, we're looking at band 1 brown, band 2 green, band 3 red. So we're looking at a 1.5 kiloohm, so we need 1.5 kiloohm on that. Okay, resistors, that's that. Let's unsolder capacitor 528. So 528 is this little mother here, Mother Hubbard, which has just come off. 528. Horizontal output stage. We could be onto something here. Blown capacitor in the horizontal output stage, dodgy resistors in the vertical stage. We might be onto something. Horizontal output stage 528, which is, funny enough, a model of BMW, or certainly was. Okay, I think it still is, although nowadays it has a 2 litre 4-cylinder turbo rather than the straight 6. And it used to have either an E28 and E12, it would have been an M30, 12 valve, single overhead cam, and subsequent models it would have been a double overhead cam, 24 valve affair, can't remember the exact number. Anyway, waffling. Come on, out you come. So this is the problem here, is it just gets a little bit stuck when you try to remove it. Oh, something else I forgot to mention, this is not an isolated chassis. So if you are doing any work on chassis which have big yellow labels on them saying chassis always live, be very, very careful, because they will bite, and they will bite hard. Might also be worth replacing, or actually no, we'll get those values measured before we do anything about replacing those. 528, which is this one. I think I've done the top one, that's why. I need to do the bottom one here, which is this one. So, doop, there we go. That comes straight out actually. And that one. That's gone as now as well. So 528 is ready to receive a new ceramic capacitor. Grab a photo of that, because that would be useful when we're sourcing replacements. Do 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 do. Okie doke. And it says 270k on it. So that one is C528. So C528 is a ceramic capacitor. Let's see if we can get some values off of it with our little tester. Barely anything to attach onto there, but it seems to be, which is handy. And onto there. There we go. Just let that drift mid-air. Hit start. Testing. Unknown or damaged part. That's good, because that does suggest to us that that is knacked, which is the technical phrase, obviously. Okay, let's try it again. 355 picofarads. Now the thing is, I don't know if that's actually a true value. So it reads 355 picofarads. Let's have a look at my ceramic capacitor pack. 300 picofarads is the closest that I've got as a potential replacement at 50 volts. I'm not even sure what voltage this one is supposed to be. It's 270k. So 25 volts there, so that's a 25 volt point. 160 volts there. You see, this is why you really need a circuit diagram for these things, because it's just guesswork at the moment. The best thing to do would be to wait until I can get a capacitor of the right value rated at as high a voltage as possible, just to be 100% safe. Oh, here we are, TDA 3651, that I believe is our field driver. TDA 2579, that's obviously our field sync. So we need R411, possibly R414. Yeah, so that is needed. We need C528. It reckons it's a 355 picofarad device. Let's have a look at the one next to it, which is or the next blue ceramic ones. There's a little brown one in there. That one is, I think, the same. That is C. Where are you? C523. So let's have a look at that one. So let's just drop that. Put that onto there. There. Actually, I've got an idea. If I borrow the... Let's turn this off. If I borrow these, I can probably just borrow the tips of these. Nah, that won't work. Ignore me. So 523. There. Try and hold those in place. Up and hit start. Unknown or damaged parts, but that might be. I've gone the wrong way around possibly. Let's try that again. That's possibly because we went down too far. 523 there. One 150.7 microfarads. 150.7 C523. It's another ceramic. 150.3 microfarads. That could be a little bit high actually. Hopefully we'll be able to find out the values of those if I can do a bit of investigation later, see if I can get some kind of circuit diagram for this. So far we're looking at R414, C528, C523 possibly, C522, let's see what that is measuring out at. It's actually got nice strong terminals on the bottom of it. So that's C522. C522, 150.3 microfarads. C522. That's another ceramic. 150.3 microfarads. C158 is a big one. Let's see what that measures up at. It's not technically part of the circuit, but it'd be interesting to see anyway. Testing. It's quite a big one, so 40 picofarads, that doesn't sound right. Look at the size of it. Yeah, I think this might be good for smaller capacitors and components rather than trying to test those massive ones. Okay, what else? So we're going to leave the IC in there for the moment because I'm not convinced that that might actually be at fault, given that we've got a number of components in the horizontal and vertical shift stages, which really are not too happy. And they do, looking at the tracks here. So that's our line output transformer, and if that's had flashed over, that would have gone through these components here, definitely. Possibly into this stage as well, so it would have taken out quite a wide field of components. So, actually, let's check this diode D508. Just interested to see if it still works, because that could also cause issues, being as it's connected to the locked. Probably better if I have the multimeter for this one. Yeah, it's given us something. So there's definitely, thinks it's a capacitor, but this is a capacitor tester. Right. Also tests transistors as well, apparently. Multimeter. Set a resistance value. So infinite resistance is 1. We want to have no resistance, so which will take it to 0. So let's go the other way around. I might be measuring this wrong. That's better. So that diode shows 0 ohms resistance, which is exactly what you want. So that diode there is okay. And that incidentally is D508. So far we need, according to our list, C528, R411. So C528 is a ceramic, apparently it's 355 picofarads. C523 is also ceramic, apparently 150.3 microfarads. C52 another ceramic at 150.3. Now I'm going to unsolder C523 because I'm not convinced that that is the correct value. Or is there enough leg? No, there isn't, I don't think. Actually, let's lay this down. We might find that there is, if we just get off the G2 controller, we might find actually that there might be enough leg on there to get our tester onto. So let's go in here. We'll also test 523 again. So get this leg out the way that we took off. Power is off before I did that, so don't worry. I want to go into, put it this way so it hooks inwards. No, green one on first. So green. Right, that's on. And red. Just hold red in approximately the right place and hit start. It's measuring at 41 picofarads. Is that what it was measuring at before? No, before it was measuring at 150.3 microfarads, so now it's measuring 41 picofarads. Could be a lower value, and I do have a 40 picofarad at 50 volts, but as I say, I'm not sure if these are rated for a higher voltage. I don't want to be putting in lower rated components because that's how fires start. Alright, let's measure 522 again. 522 is an unknown damaged part, might not be making contact properly on that leg there. Let's try that again. .40 picofarads, so 522 was measuring. Let's cross out that top value and that value. So that was, those two were the same, so that's 40 picofarads, and that's actually measured at the capacitor itself rather than on the board, and the board itself could be introducing some duff readings, which is always a possibility. So that's our vertical stage. Now we've got R408, which is R414, R411. So R411 needs to be replaced, and that's our 1.5 kiloohm. R414 is measuring at 660 ohm. So let's put stars next to the ones we want to replace. Put that on here. Equals replace. 528 star, 523 star, 522 possible star as well. So we're looking at R408. R408. Okay, R408, according to my calculator, we are looking at a brown, black, red, 1 kiloohm plus or minus 5 volts. 1 kiloohm. Why do I not have any of the resistors I need? That's always the way, isn't it? So we need a 1 kiloohm for that one. So that is 1 k ohm. And measures out at, let's just grab that off there, grab that off there. Dun, 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 dun. Yep. Hook the old chassis up, looking at 408. Ooh, don't go back in there. 408. So rest that against there, hit start. We're looking at 408 312.2 microfarads. No, you're not a capacitor, you're a resistor. still thinks it's a capacitor. Okay, let's borrow that. So we want 1 kiloohm. So let me borrow the multimeter. Switch it to 2K ohm mode, which should be enough. We are looking at R408. R408 is measuring 751 ohms. So that's slightly low, that's gone low in value. 751 ohms. So that has gone a bit low in value, that one. 414, we've measured, that one that's low in value as well. Do we have any resistors in the horizontal phase? Yes, we do. R502, which is inside. Oh, oh yeah, blimey, that's right in there. Right by the locked. You can see the colours that it's supposed to be. Right. Oh, that's an interesting one. So, R502 is our next one. Okay, let's measure it first. R502 is measuring out at 001. 0.001 kiloohms. Let's work out what it should be according to the nifty calculator that I've got for the phone here. So, colour wise, we are looking at 2 reds. So, red, red, red. No, James. Red, red, black. 22 ohms. So 001 kiloohms would be 10 ohms. That one should be a 22 ohm resistor. 22 ohms. So that might need replacement. Do 502. It's a link. Oh, the A51591X. This chassis is obviously used for a 20-inch set as well. That's the only resistor I can find so far in horizontal line spool, which is the horizontal line coil. I'm not sure we actually go that far, to be honest. It's more horizontal output stage, I think, is what it's taken the brunt of the impact from the failing locked. Locked has been replaced, and there were a number of obviously damaged components. So I think for now we've got enough to be going on with, certainly. Anyway, what we will do now is we'll put the chassis back together, and the next stage will be to get some of those components replaced and see where we are following replacement of the components. If you found this video interesting, don't forget to hit that like button and also consider subscribing for more upcoming fascinating hobbies. Thanks for watching.